We saw that the general solution for a 2-degree freedom system takes this form, okay? And what I've done here is I've replaced those cosine terms with the cosine and sine terms for the sake of argument. And with initial conditions, what you do is you take time to be 0. And obviously certain things will happen to these terms when sine and cosine, when time is 0, so the cosine and sine terms. A1, A2, B1 and B2 are determined by their initial conditions. And like I said, what you do is you define x1, x1 dot, and x2 and x2 dot when t equals 0 to be certain values. Obviously here we've defined them we've defined them to be 0, so where everything's initially at rest. Generally that won't be the case, but what we do is we take the first derivative with respect to time. So there's our solution to find x1 dot and x2 dot. And when t equals 0, so if we went back to the first, so this is when t equals 0, okay, for the displacement, cosine times by 0 is 1, sine of 0 is 0, so that disappears, as does this term. And so we end up with x1 at time equals 0 equals a1 plus a2. x2 equals r1 a1 plus r2 a2. And if you do the same thing with the derivative term, x1 when time equals 0, obviously this term now disappears. We end up with b1 omega 1 times by 1 plus b2 omega 2 times by 1 because the sine term disappears. And obviously with x2 you've got the same thing except it's multiplied by r1 and r2 as well. And so you end up with 4 equations and 4 unknowns. Okay, so you can solve it. A1 and A2. Okay, and B1 and B2 are our 4 unknowns. Everything else we should know. We know our natural frequencies and we know our values for R. And so we can solve it. And question 2 in your exercises is giving you the initial conditions and you go through and you solve for those initial conditions.